So we are starting with a very simple question. What is a binary operation? Maybe if we know what it is, it's going to be easy for us to understand the whole thing here. I've just started. I hope you're able to get me. In trying to answer the question, what is a binary operation? We illustrate using some examples and then give it a very simple definition. So, suppose 1 let me put it. Suppose we have a set. Suppose A is equal to -1, 0, 1. This is a set, and star is defined as A star B is equal to AB, the product of A and B. So we have defined the star. We define this star here in such a way that A and B are members of A. So you have A and B members of A, meaning that it's either A is equal to -1, 0, 1, and either B is equal to -1, 0, 1. These are the only options that are there for B, the only options that are there for A. You can only pick A and B from these options. Now, star is saying, if you pick, suppose you pick A to be 1 and B to be -1. When you take this to star, you have 1 star -1. What does it require you to do then? Star is saying, get their product. 1 multiplied by -1, which is equal to -1. That is what star is doing. It's just telling you that when you get two numbers from the set A, multiply them. If I get A to be 1 and B to be 1, star is still saying, multiply them. I'll get 1. Then, if you get -1, star -1, star is still saying, multiply them. I'll get 1. If you get 0, star 1, star is saying, multiply the two numbers. You get 0. You get -1, star 0, star is saying, get their product. You get 0. You get 0, star 0, star is saying, get their product. You get 0. So many combinations that you can make here. And you are taking them to star, then star will tell us what to do to those two numbers. So you come and say, no, I have two numbers. I have 1 and -1. Star, what do I do to these numbers? Star will tell you, oh, multiply them, get their product. Then now, after you've done this, a question follows. What is that star? What is that star? This star can be anything. It can be anything. It's just an instrument that is giving us instructions of what to do to two numbers that we pick randomly. But if those numbers are in A, the way star has behaved so far, we suspect that star is binary in A. How does the word binary then come in? So you say star is a binary operation on a set A if for all A, B in A star B is in A. Simply saying, if we pick two numbers A and B from the set A and act star on them, the answer should be a number that is also in A. As you can see, we got 1 and -1. Multiply the two numbers, we still got -1. So -1 and 1 came from A. The answer we got, -1, also is in A. That is the key definition of a binary operation. You always talk about an operation being binary on a specific set. It will only be binary on that set on a serious condition that if I pick two elements of that set, whatever I do to them, the solution that I get should also be an element of the same set. As you can see here, you get 0 and 1, multiply them, you still get 0. You get -1 and 1 multiply, you get -1. You get 1 and 1 multiply, you get 1. -1 by -1, you multiply, you get 1. Whatever answer you get is an element of A. If you use the elements of A to get that answer. That is how we define a binary operation. Who wants to tell us what a binary operation is? Gabriel. Yeah. Hey, okay, it's back. Gabriel. Okay, let's go to Barry. Barry. Kathy. Charity. Joshua. You guys don't want to say what a binary is. I want you to say it in what have you understood so from this thing here?
Sir, for some of us, explanations are too tough for us. Maybe you just give us the question we thought for you.
All right. Okay. At least you have said one or two words. Okay. So,
Sir,
yes.
I can say something from what I've understood. Okay, it's like you combine two elements of the same set, which will give you another element but of the same set.
So if we find an operation that will combine those two elements in such a way that the answer we get is coming from the set where we got those two elements, that thing that we use to combine is called a binary operation. Okay. So, if, yes?
I'm asking if you can kindly repeat. I was logged out.
Okay. So, if you are to call something a binary operation, if we give you two numbers, P, Q, let's do this, R, these are elements of the set A. Then you get star from somewhere. Then you pick P star Q. It gives you R. You pick P star R. It gives you P. You get Q star P. It gives you Q. Then you get Q star R. It gives you R. The fact that any way that you use to combine P and Q, P and R, Q and P, Q and R, if this keeps on happening, that every time you combine, you get an element of the same set. Every time you combine, you get an element of the same set. Then we'll say this combiner here, this is that we're using to combine, is called a binary operation. On the set A. So an operation will be binary on a condition that whatever we do to the elements of that set, using that operation, we still get the elements of the same set. Then we'll say that operation is binary. That is how we define it. Okay. So star is a binary operation on the set A if for all A, B in A star B is an element of A. Then now we have used just wait throughout. If we pick two numbers, A and B, from the set A, and act star on them, the answer should be a number that is also in A. That's a very good point. Star has two features. Star has two features. commutativity.
Associativity.
So first talk about commutativity, then we'll bring in associativity. Commutativity. This one we've talked about it in sets. In sets, we say A intersection B is the same as B intersection A. So sets are associative. The sets operations are associative in that manner. I mean, are commutative. Then now we come to binary. We say a binary operation star is commutative if A star B is equal to B star A. Let's see. One is star commutative. A star B is equal to 3A plus 3B. B A star B is equal to 3 A B minus A squared plus B squared. And then C A star B is equal to A minus B squared plus 2AB. Okay, let's start from here. So let's go to A. By definition, A star B should be equal to B star A for the operation to be commutative. Now, A star B will always be your question. It will always be given in the question. Your job is to check what B star A is. B star A means in your question, where you have A, put B. And where you have B, put A. Do the same on the right. Where there is A, put B. Where there is B, put A. So this is going to be 3B plus 3A. Now we compare. But this is equal to 3A plus 3B, which is equal to A star B. Hence, star is commutative. You just want to see if this is the same value that you are getting. This is your question. This is B star A, but they are equal within A star B. Like that. Okay, let's go to B. We already have B star A, so go straight to, we already have A star B, so go straight to B star A. B star A is going to be 3BA minus B squared plus a squared. If you compare this guy, you can write this guy as 3ab minus a squared plus b squared, which is the same as a star b. Hence, star is commutative. See, you have a star b already given. All you want is b star a. Now, b star a is going to be b minus a squared plus 2ba. You can expand this for you to see properly. Say b minus a multiplied by b minus a plus 2ab. This is b squared minus ab minus ab plus a squared plus 2ab. This is b squared plus a squared minus 2ab plus 2ab. So now I can see minus 2ab plus 2ab, that is 0. So you end up having b squared plus a squared. Now we did not expand the question, the a star b. So let's now expand a star b. A star b is a minus b squared plus 2ab, which is a minus b multiplied by a minus b plus 2ab, which is a squared minus ab minus ab plus b squared, which is a squared plus b squared minus 2ab. And so here I forgot to put plus 2ab, which you put here now, plus 2ab. This one in the question. So we get 0 here, and we end up having a squared plus b squared. If you check, this is equal to this. So this implies that a star b is equal to a squared plus b squared, which is b star a. Hence, star is commutative. That's how you check. Okay. Now we define another property of this star called commutativity, associativity. So a binary operation star is associative if a star b plus star c is equal to a star b star c. On commutativity, you just need, you're just trying to check if the order does not matter. If when I start with A and then bring B, I'll get the same thing as starting with B and then A. What if I make a mistake while there is A, I write B? While there is B, I write A. Do I still get the same answer? For example, 2 star 4. Is it the same as 4 star 2? If they're the same, we are saying then star is commutative. So I'll bring in numbers from the Tutorial sheet, of course. There we'll look at some numbers based on the same. Associativity. A binary operation star is associative if A star B star C is equal to A star B star C. What matters there is the order. Because the star takes only 2 elements at a time. Your question is, does it matter which 2 elements I start with? Can I start with A and B and then extend to C? Or I can start with B and C, then extend to A. You don't change the order that you switch, you say A star C. Example, so that you can see what you're talking about. Is star associative on R? A star B is equal to AB. B, A star B is A minus B. C, A star B is 2AB. For A, the definition requires that we should have A star B star C equal to A star B star C. Here you want to check. If I start with this, then involve C, do I get the same thing as starting with B star C, then involve A? A star B has been given in the question. It's AB. So while there is A star B, you write AB. Okay? Now we'll pick, let's pick the left-hand side. A star B star C. What is A star B? A star B is given in the question as AB. So while there is A star B, you write AB. This as one element, star C. We now only have one star. The other star has been used to give us AB. This means we have our new A. This is our new A. This is our new B. So when you combine them, we should have AB. But what is our new A? Our new A is AB. Our new B is C. So we get A, B, C. Then we pick the right-hand side. Now you start with B star C. So what is B star C? So in B star C, your A is B and your B is C. So you need to have AB. But A is B, A is B, and B is C. So when we go to A star B star C, you have A fixed. This B star C have been found here as BC. So we write BC. Now we have our new A. This is our new A. This is our new B. So you multiply them, you get AB. But what is our new A? Our new A is 2A. Our new B is BC. Expanding, we get ABC. But if we check, these two are equal. So the left-hand side is equal to right-hand side. Hence, star is associative. So the key thing is following the, like we used to call it BODMAS. I don't know how it is called now. If you follow BODMAS, you start with the brackets first. That's your target. So since I have to deal with the A star, B star, C. I have three things, but the definition of star, it only needs two, one on the right, one on the left. So pick A star B. It will give us AB. Okay, so you operate first the brackets. You get AB. In the brackets now, we have AB, which is a product. Star C, the C rating, now you extend. At each point you will deal with the star, you only have two things surrounding the star. One on the left, one on the right. Whatever sits on the left, go in the definition and let that thing be A. In the definition, that thing will sit where A is sitting in the definition. So now instead of having A, we have AB. Instead of having B, we have C. When you simplify, you get this. When you go on the right hand side, the bracket you have BC. This B has become our A, has become our B. So get BC as a product. And then we have A star B star C, but we know this. This is BC. So now we have A star BC. And get as a product, you get ABC, but the two are equal. So what we do now is this. We off for 10 minutes as we do B and C. Let's check. Is the star associative there? Please, let's check. And then we join at 18:55.